and thanks everybody for the great presentations. Today I'll be talking about exploiting cross-document messaging, part of web messaging. Let me just get through the agenda. Leo, can I get yeah. For some reason, Leo, it does not receive. Okay, great. So I'll start by explaining a little bit what cross-document messaging is, why is it's actually being used in many places. I will go through threat and attack models for this technology. So it's not a new technology, but it's a little bit under the hood. So at the moment it got my attention, I thought that the best way to approach it is by doing proper threat and attack models to see where you can actually start your reconnaissance. We'll talk about the fact that it's a little bit different than other technologies where we have good tools to research and what we did with it. Discuss an example for an exploit that uses web messaging, cross-document messaging to be specific to tamper with remote origin. And we'll conclude with some tips to developers and tips to security researchers. So just before we do that, one slide about me. Okay, so I'm Chen, I live in Tel Aviv. Most of my career was pen testing and around application security in general, but I always loved to build tools for what I did, and doesn't matter what kind of project, I always enjoyed bringing my own developer skills to the table to build tools to do the task in a little more effective way. Which led me and my partners also to build Enso.security, and also led me, and also was most of my focus in this specific research where I built a tool to help the community research this kind of implementations. Let's get to what cross-document messaging is. So cross-document messaging is essentially window-to-window communication between documents that are loaded in the same window environment. So in your browser, the browser, in every tab, there is a window object that hosts all the frames, all the different documents that load into it. The first window belongs to the origin that you loaded from your URL bar. And then inside, it can embed additional windows. Each and every one of them will have its own window object enveloping the document that is actually implementing your web, your HTML application. And this technology allows all documents that are loaded within the same environment to communicate with each other. This communication does not include network in any way. You won't see it in your burp session or in your fiddler session, or you won't even see it in your network tab in the developer tools. So it's a little bit hidden from the eyes of security professionals at the moment, although there are some tools that can help you see it, but it's not very visible to the eye when you do standard web application research to find vulnerabilities. And like the more modern web standards, it has a rather straightforward and simple security model. Let's start with talking about its functional flow. So these are two windows. They are loaded in the same window environment, which means that they share either one of them or they share a shared top window. It doesn't matter where in the hierarchy of windows. So imagine that you have a document that loads a handful of iframes inside. It doesn't matter where in the hierarchy of the window all the way to the top you are. You can always send to anyone. You can always send to your parent, to your sibling, to the grandchildren of your parents from another branch. This is how it works. This is how it was designed. And on the recipient end, you may or may not implement a handler. It will receive it. You can send it on between all the frames, but you may not implement a handler. If you want to do something with messages you get from the other side, you simply use standard web API to register a new event handler on the window, on the window, and you will receive messages sent to that window. Let's talk a little bit about the security model. So on the environment, Windows can try to avoid loading in a dangerous scenario, meaning that I, as a window, would not like to be embedded into another window. I can do this with the no next frame options, but this doesn't restrict anyone from opening me with window opener on another tab. We do have these more recent security, cross-origin security policies to restrict. So a window could, by its response headers, by security policies, say, I don't want to be opened by another window and still give a handle to that window. So you can work on the environment of your document, of your HTML document, to say this document shouldn't be loaded with connection to other windows, but this has limited browser support, and it's actually sometimes not possible. Sometimes you do need to talk to other documents. Why actually, maybe it's a good point to say, why would people do this? It's very useful to communicate with ad networks. It's very useful to do login scenarios where the actual identity provider is coming from another origin. And in any situation, when you have multiple origins that share same resource, it's an alternative way to do it than using cross-origin Ajax calls. And it simply works. It's useful in many ways. So this is what developers do use it in actually in many ways. It's very, very common when we talk about ad networks. So this option is not always available to you. The second part of the security model, which is not about your environment, it's actually about your specific implementation, is how the actual user code environment looks like. So on the sender code, you have to specify the remote origin. And the reason for this is because you are sending to a window object. You cannot tell what document is currently loaded in it, because if these windows have been through a redirection process and another document was loaded in it from another origin, because it is isolated from you, you have no way of asking what it is. In fact, a very weird implementation, you can change it, you can force it to redirect, but you cannot ask what it is. And this is why you have from the browser API an option to, or you have to actually say what kind of origin, what domain address you're expecting on the other side. You can, however, say, I want to be sending to whoever it is by using asterisk. On the receiver end, the browser will give you authoritative information about who sent this. So the browser will give you inside of the message, the received message, information that you can trust, that tells this was sent from chen.com. And then you should be testing this and authenticating the message this way. Very simple security model. You have to test to authenticate the remote. You have to send restrictedly, and you can avoid loading yourself in risky scenarios. Something very simple, which makes it a bit more simple to do a threat model on it. So threat model, I'm using Stride. For Stride, the ground zero is the window. All of the players in this scenario are loaded in the same window environment. And in this window environment, we can host documents from different origins. And the rest of the scenario, after the documents have been successfully loaded into the same environment, and the rest of Stride flows this way. So your spoofing option is the main option for you to actually get into doing some actual damage. Will be focused either on the sender document or on the receiver document. If you want to trick the receiver document, you will try to mount it somewhere and send messages from identity that they weren't expecting to be getting messages from. So you can spoof the sender by simply opening and loading your target document in an iframe and start sending messages to it. You have a spoofing option here, and this is the threat, and the developer on the other side should respond accordingly by authenticating this. In a similar fashion, you could be spoofing the parent, or actually not the parent, but the receiver document. You can craft an environment which your victim document is loaded side by side with your malicious page, and receive messages that weren't intended to you because the sender may be sending unrestrictedly. So this is the second part of the threat. Sender is sending unrestrictedly. You can spoof the receiver end. Once you've been able to spoof this, another threat arises where the sender is sending sensitive information, and you have managed to mount it and start listening to messages. You will be able to capture this information. This will include sometimes tokens, sometimes secrets that fall from one way or the other, sometimes just leaked personal information that ads network like to share about us. So you will be able to disclose this information. On the other side, on the receiver document, which is the more interesting part, depending on what the receiver script implements. So if you've been able to spoof your identity or to go past the authentication check on the receiver document, you will actually be able to trigger the handler directly. It's as if you call the handler directly from their code, and then it depends on the handler. So the research and understanding threats here would go into understanding what the handlers actually do with the incoming messages. And from our research, they do all sorts of funky things and just some really interesting implementations and hacks. Let's go into talking about our two attack models. So we have one attack model with a very simple one and not so common, where the malicious window is the receiver window, and the receiver window is mounting the sender window. It's using the weakness, it's abusing the weakness that Windows may not restrict opener, meaning that they didn't configure the cross-origin policies to restrict and X-frame options to disallow loading them in some scenarios, and that the sender script may send unrestrictedly with asterisk. In this case, you will start getting the messages, and this is our first attack model. The second attack model, which is the more interesting one, the sender document is the malicious one. It mounts the receiver document. It abuses the weakness of the window may not restrict opener again. It's the same opening weakness. And then the weakness on the receiver script that is being exploited, the developers may skip authorization check. And I think this is the biggest weakness here. Developers are sometimes not aware. Maybe they think we have X-frame options, so we have no problem. We don't need to do this check. But you can open a window on another tab and still have a handle to it, which means that having XFO won't help you here. So this is our second attack model. Let's talk about how to, sorry, I was expecting another slide here, but the missing tool. Let's talk about how you can actually find these kind of problems. So for the first scenario, you need to mount frames and see the messages that they send and see if you see any interesting information. So you want to be finding servers and simulate malicious receiver to see if you see any sensitive information. For this, we found a lot of tools that mounts, that maybe works as an extension and just shows you a log of incoming traffic and just let you maybe see the function who received it. However, to find receivers and simulate a malicious sender in this complex environment, it was really, really difficult to go past all the complexity of how windows can load each other and to actually visually see a situation where windows are properly loaded and trigger the actual attack simulation. And this made this research super interesting for me because first we have technologies that is broadly used. It has some inherent weaknesses, very simple, straightforward one. It has a very simple and straightforward security model, but it has some weaknesses. And our community, the AppSec community, wasn't really able to test it because there weren't good enough research tools for this. Like if we compare this to what we have in normal web application testing with Burp Suite, for example, this is way beyond. We don't get even half the visibility we get with Burp. So for me, a broadly used technology with not a lot of visibility for application security teams means that it will probably be bountiful research in this area. And this is why I went about it and started together with two of my friends developing Posta. It was actually called Post Apocalypse, but it's not so appropriate now, so we call it Posta. This tool is basically a home extension. It has been through, I must share with you this because it's been through many painful cycles of trying to get this information in a stable way from the browser. I went through trying to open in the browser in debug session and recording everything from there, trying with extension, going back to many, many different techniques. We had another version that was actually working by injecting it from burp, but it was really, really painful, to be honest, to build this. But I'm happy with the result because what happens now is that we have a Chrome extension. You open this Chrome extension, it will immediately start tracking all your tabs. It will show you the tree of tabs. It will show you which messages flow from one way to the other. It has limitation in seeing all of it because it is dependent on the way that the browser is injecting extension data into the different parts. And it's, like I said before, it's super complicated. So you won't be able to see some of them. So for example, you can create an iframe by creating an iframe and giving it a data URI URL, which will create a real HTML document, but has no origin and has no proper environment for the extension to be injected. And then you will see in here that that is not properly injected, and it's not exactly also a very interesting target because it's a null origin document with some HTML code. Feel free to go over to Benzo.io. It's Enso's open source community project. We will be, this is our first tool there. We will be also contributing with more of our projects or more research in the future. Would love for your feedback on how this tool works for you and for our researchers to find some cool bugs. And using this tool, we were actually able to detect problems in cross-document messaging very, very quickly. I was very focused on building the tool together with my partner and also our CTO, Barak, and with our friends, Omer Yaron. We worked on some of the research. And as part of this research, we found in many, many places, this example show an eventual payload that used to do cross-site scripting scenario in AliExpress. So what happens, this actually shows the flow of cross-document messaging attack. You mount a window in the right URL. This window already implements a receiver script that is weak, which means it doesn't perform the right test. And on top of not performing the right test, it also is not avoiding being loaded in this scenario. The test that it should perform is to check where is this coming from, where this message is coming from, but it accepts messages from everywhere, which means it doesn't test in the receiver code. Sending the exploit is actually getting a handle to the content window of the iframe, this specific window, and posting the message, this payload, which is a complex payload that was actually captured using Posta in the normal log of the operation and tampered with to be sent again to actually cause this. So this message was sent from a frame to the top window and was configuring local storage items that implement parts of this menu. The flow is very simple. It looks like a CSRF attack almost, but what happens is that we load the exploit. The exploit is issuing the post message requests to the window that is opened here on the side. And after this is successful, to an iframe that is loading here inside. After this is successful, the actual data that is used to build this menu by AliExpress is altered to this result. You see that it's added another menu item with an overaction that actually trigger cross-site scripting like attack. So it's not DOM-based cross-site scripting because it happens from another document. It's not reflected. It doesn't involve network at all. It's just simply running. It's very similar to CSRF experience, but the target of the attack is the actual document loaded on another window. So let's conclude with talking about what you should actually be looking for when you want to find these kind of bugs. Sorry, let's conclude with the top messages here. By default, windows can send data to each other. If you didn't do anything to make sure that your window cannot load in any problematic scenario, other windows will be able to mount it, to embed it as an iframe, to open it in a tab, to actually send messages to it. So don't be fooled by this. If you are implementing an event listener for messages in a document, you should make sure that it's not possible to load it in a risky environment and send messages to it. The only way that we've found so far to do this is to basically go over these implementations and take a look properly into both sides, and especially on the receiver side, to see that the implementation of event origin check is done. For the engineers amongst us who wants to implement web cross-document messaging and stay safe, first of all, try to restrict the runtime environment, so to avoid loading as much as you can in risky scenarios. If you only want to be cooperating with one origin, restrict this origin. Allow only this origin to work with you. If you're working with multiple, really consider what is your approach here. Always send explicitly. Never send with asterisk. Use always the explicit target to send a message. And when you're receiving message, always check the event origin, but make sure that you are not exposed to regex bypass techniques, because this can also easily happen if you're checking the origin with a regex. Also want to thank my friends that helped me with this research. So our CTO Barak and Omer, we did parts of this research together. It was really, really fun. Yes, one word about where I'm at right now. I'm working on Enso.security. Enso is an ASPM, allowing managing application security programs in large scale. You're all invited to come and check our website, and also approach me directly to discuss more if this is of interest to you. Thank you very much.
Okay, Chen, thank you very much. Guys, do you have any questions? Please write it down in the chat and QA.
So I see one question about Vue. As far as I know, it doesn't matter what is your framework, if it's React or Vue or using vanilla JavaScript. It's an inherent issue in documents in HTML. I mean, there is an inherent weakness in the basic security model. Like every security model, it has its weaknesses. So it doesn't really matter, as far as I know, what kind of library you're using.
Okay, there is another question from Adam. Are we talking about a JavaScript message listener, or any others?
We are talking about specifically messages to the event listener message on window. So it's a special kind of JavaScript listener. You can only mount a listener on the window object, and the type of message is a message object, and it has a special situation around it. It's not like any just dispatching message. I'm not sure about what other message listeners you're talking about. We are talking about strictly JavaScript environment inside the browser.
Okay, there is another question from Anonymous. What exactly does Posta search for or filter by?
Does Posta, you mean the tool?
The tool, yes.
Where is this question? It's in the Q&A.
Yes.
So it lets you see the entire structure of all the windows that are currently loaded in a tab, and to see which window is sending messages to which other window, and see all these messages. Once you spot it, once you load it, and you load your research subject, the document that you want to look at, so you browse to the website you want to be checking, Posta will populate all this information for you in its UI, and will let you tamper with messages and resend them to see if there is an effect. So if you see a message that seems to be triggering a change of some sort on the remote end, you should load it, tamper with it, and try to resend it to see if the recipient end is affected in some way. And then you can move forward to use an exploit, but it doesn't try to detect it itself. It's a tool for researchers, for security researchers that normally would use burp to do the research, but in this situation, burp is not useful for us, and we need a tool that will give us eyes into this communication channel.